In this lesson, we're going to be graphing y equals sine x and y equals cosine x with transformations. We're told to graph one period of each of the following. For each graph, we're going to answer the following questions. We're going to give the amplitude. We're also going to be given where the period begins and ends, and this means at the x values. So go ahead and record that up here. When this question asks you where the period begins and ends, it's asking for the x values. We're also going to give the length of the period. For sine and cosine, remember the length of the period, or the period, is the formula 2 pi divided by whatever the value is of b. We're also going to be stating the x-intercepts. We're also going to be given the maximum and where it occurs, at what x value. So a maximum is a y value. We're also going to be stating the minimum, which is a y value, and at what value of x that occurs. We're also going to record the domain and range of our graphs. All right, so for example 1, notice that we're going to be graphing y equals 1/2 times sine x. So right here, I would say it's best to go ahead and list all the values for a, b, c, and d. So a is 1/2. B is the coefficient on x, so that's just 1. All right, C's value from our previous notes would be found if we have any parentheses being added or subtracted to the x. And again, D is going to be your shift up or down, and it'll be attached as a plus or a minus. So for this equation, we don't have any parentheses, any shift left or right, so our value of C is 0. There is no plus or minus here, another term, so D is also 0. All right, so for this graph right here, probably the best way to produce 1/2 sine x is to start with the key points on the parent function, and then apply any changes, produce new points down here, plot these points on this grid, and then go back and answer these questions. All right, so we have identified A through D's values. So let's go ahead and come over here and record the formulas from our notes previously. Any changes to x coordinates on this graph will come from 1 divided by b being multiplied by x plus any c value. The new y coordinates on the transform graph will come from multiplying any a value times the y coordinates on the parent function, adding any d values. So that's our formula. All right, so down here underneath the new point line, I'm going to go ahead and apply any changes to this formula. So I'm looking at 1 over b, so I'm going to come back over here and look at the b value in my equation. It's 1. So I'm going to take 1 over 1. I'm going to multiply that by x, and I'm going to add any c value. Well, c is 0, comma, a times y plus d. A is 1/2. We're going to multiply 1/2 by all the y values of the key points, and we're going to add 0 for d. So let's come over here and clean this formula, this new formula up here. So 1 over 1 is just 1, so that's just x, plus 0 just gets x. And then here, cleaning that up, we just get 1/2 times y, or you can think of it as y divided by 2. So what this formula tells us is that for all key points, we'll make no changes to the x, but for all the y coordinates of the key points, we'll divide those y values by 2, or multiply by 1/2, however you want to think about it. All right, so we identified A through D. We applied these values to the formula up here. We came up with the new formula for the new points. Let's go ahead and record the key points for sine. Remembering back from our previous lesson that these are the 5 key points. Sine always starts at 0, 0, whereas cosine starts at 0, 1. All right, applying this formula, I can see that my 5 new points, the x coordinates will remain the same. So I'm just going to take and record all the key points x coordinates here. I'm going to populate the first coordinates here. But for the y coordinates, I have to divide all the y values of the key points by 2, or multiply by half. So 0 divided by 2 is still 0. 1 divided by 2 is just 1/2. 0 is here. I guess that means 0 will go here. And then negative 1/2 here. Now that we have these new points, we can come over here and graph. Okay, I see that my first x coordinate is at 0. My last one ends at 2 pi. So I know that it says y right here for the y-axis, but I'm just going to kind of ignore that. And I'm going to put the y-axis where I want to put it. I'll put it about right here. Since all my points go from x equals 0 to 2 pi, most of the graph will be to the right of, at least what I'm graphing will be to the right of the y-axis. All right, so 0, 0. Notice the increments of the x coordinates count off by 1/2. You can use as many tick marks as you want to represent that first horizontal distance of pi over 2. If I only used one tick mark for pi over 2, the graph might be kind of crowded. So I think I'll just say, you know what, let me use 2 tick marks to be this horizontal distance between consecutive x's. So another 2 tick marks will put me at pi. Another 2 would put me at 3 pi over 2. All the way to 2 pi. It's possible I could have probably used 3 tick marks to represent a distance of pi over 2 and used up more of this space, but this will be fine. All right, now the y coordinates. So 0, 0, got it. Pi over 2 here goes up as high as 1/2, come back to 0, down as low as -1/2, and back to 0. So use as many of these blocks as you want to represent a distance of 1/2. So maybe I'll just use 2 and say that that height is 1/2. So I have to also use 2 here to say this is -1/2. So at pi over 2, I'm up here at 1/2. Pi, I'm back to 0. 3 pi over 2, I'm at -1/2. And then I'm back to the midline here at 0. Okay, no sharp turns. Make it bend kind of downward this way, turns back this way. Looks good. Now we have to complete all these questions. Okay, what's the amplitude? Well, it's 1/2. It's the absolute value of the A value. All right, B, where the period begins and ends. So x equals 0, and then it ends right here at x equals 2 pi. So if I were to subtract these two values, that tells me that the period is 2 pi. Another way to think about it is to take 2 pi and divide by the value of 1, which is b. I'm still going to get 2 pi. Do we have any x-intercepts? Yes, we do. We have 3 of them in this period. Question E asks us for the maximum value and where it occurs. So y equals 1/2 is the highest y value at x equals pi over 2. And minimum y equals -1/2 at the x value of 3 pi over 2. All right, domain, well, that's going to be all real numbers. That graph has no breaks in it. And the range, the smallest y value to the highest y value, we want to use brackets because the graph does reach -1/2, and the bracket includes that y value of -1/2, and then +1/2, ending with another bracket. All right, just practice. Let's do some more. If I'm going to graph this, first thing I'm going to do is identify A through D. Okay, and then for me, I'm going to come down here and start to come up with formulas for the new points. So I'm looking back up here at the formula. So it's 1 over B. It's 1 over 1 again, times x plus 0. A is 2 in my new problem, 2 times y plus 0. B is 1, keep the x, add the 0. A is 2, multiply it by y, add the 0 for D. Cleaning up each of these coordinates, I just get x, comma, 2y. So you don't need to do this step if you don't want to, but I think it's kind of helpful to see the structure. You can go straight to here. That's fine. Okay, think about what this is telling us for the key points. We're going to keep all x coordinates, but we're going to double the y coordinates of the key points to generate our new points. I'm going to keep the x's and double the y's. So you could either, populate all the x coordinates first and then come back and do the y's, or you can finish one complete point. It's up to you. Zero times 2 is still 0. 1 times 2 is 2. This will be a 0. This will be a 0. 2 times -1 is -2. I think we can imagine that we're going to vertically stretch by a factor of 2 because of this a value. Just like up here, we vertically shrunk the parent function to a half because of that a value. Okay. So let's go ahead and graph. Let's plan our graphing, and then we can respond to these questions. I kind of eyeball the new points and I go, oh, 0 to 2 pi. So I want most of my graph to be over here. So maybe I'll put the y-axis again right here. Your choice if you want to use 2 tick marks to be the distance to pi over 2. Let me see if I use 3. 1, 2, 3. If that's pi over 2, then I'd have to do 1, 2, 3. That's pi. 1, 2, 3. That's 3 pi over 2. 1, 2, 3. Yeah, I have enough space. So it's really up to you. 1, 2, 3. 1, 2, 3, that's pi. That's 3 pi over 2. That x coordinate, and now 1, 2, 3. 1, 2, 3. So it really kind of spreads it out. How do I scale the y-axis? Well, I peek into the y values and I go, oh, the y values go as high as 2 and as low as -2. So maybe 2 tick marks can be an increment of 1. So that's +2, -1, and -2. Just to spread the graph out. Okay, and then we'll just start plotting. I've got the 3 midline points here. So it must be at 3 pi over 2. I'm down here to -2. Make sure you have no sharp turns, that it's rounded, real smooth. Kind of bends and turns this way. All right. Let's fill in this information. If you're comfortable, turn off the video, do it yourself, turn it back on to kind of self-assess, see how you did. A asks us for the amplitude, so that's going to be the absolute value of A, so that's just 2. X values where the period begins and ends, x equals 0, comma, x equals 2 pi. Period length can be found by subtracting these two x values or taking the formula 2 pi and dividing it by the b value. Record your x-intercepts. E asks for the maximum value, which is a y, so y equals 2 at x equals pi over 2. Minimum, y equals -2 at x equals 3 pi over 2. So the domain will always be all real numbers for any sine or cosine graph, so all real numbers. And our range here, we can see goes from -2 to +2. It wouldn't be wrong if you went 2 to -2, but common practice has us go from a smaller y to a larger y. So if you switch these, it wouldn't be wrong, but it's just not the common practice way of recording those range values. All right, more practice. All right, notice in number 3 that we have a b value now, other than 1. All right. So A is 1, B is a half. Okay, and remember that you could have written this as sine of x over 2. So either you pull the 1/2 out front or you stack it as a fraction. There are no C or D values. Okay, let's come down here and modify the formulas. So for the formula, we take 1 and we divide it by b. Well, b is a half, so we've got to put 1 over a half times x plus any c values. And then we have a, which is 1, times y plus any d values. All right, so 1 divided by a half would give us 2. Remember, keep, change, flip, multiply by the reciprocal. 2x here, comma, no changes to the y. So we're actually going to change the x's, so this is going to be a horizontal, I think it's going to be a horizontal stretch. The graph should be wider. When this b value is less than 1 whole, we're actually making the graph wider. If b was greater than 1, then we're actually making the graph more narrow horizontally. All right. If you're comfortable, pause the video, do it yourself, come back and check your work, and then go ahead and move on if you do feel comfortable. Still sine, right? Yeah. We'll probably end up memorizing these key points for sine because we're writing them down so much. I'm going to double all the x coordinates. So 0 times 2, if x is 0, multiply by 2, I get 0. And the y's stay the same. All right, doubling pi over 2, so multiply by 2 over 1, you're going to get to a pi. Double pi, 2 pi. Double 3 pi over 2, and remember what that looks like. 3 pi over 2 doubled. 2's will divide out and you get 3 pi. And then we have 4 pi 0. Okay, so we're going to come over here and scale our axes. Notice you go from 0 to 4 pi. That's okay. I'll still kind of draw it the same as I did the previous two examples. All right, the first distance horizontally goes from x equals 0 to x equals pi. So how many tick marks to go to pi? I think we can do 3 again. So 1, 2, 3, that's pi. 1, 2, 3, this would be another pi. 1, 2, 3, 3 pi. 1, 2, 3, 4 pi. Scanning the y values, notice that we go as high as 1 and as low as -1. So I don't know, I'll use 3 tick marks to represent a distance vertically of 1. And we'll just plot. All right, we'll record the answers to these questions. The amplitude is the absolute value of A, so that's just 1. What did B ask us? The period begins at x equals 0. It'll end at 4 pi, and then it'll start to repeat. So I can see by subtracting these two x values, this later x value to that earlier x value, that's 4 pi. But remember, we can get 4 pi by taking the formula 2 pi and dividing it by b, where b was a half. And we know 2 divided by a half is 4, and then we'll just reattach the pi. And our x-intercepts. Maximum, minimum, domain, and range. All right, example 4. Let's list the A through D values. So A is -2. Remember, the amplitude is the absolute value of that, so the answer for this question will be 2. B is 6, and no C or D values. We're getting there. We just need to get familiarity with these other things first. All right, down here, the formula is 1 over b. So 1 over b is 6 times x plus c, comma, a, which is -2, times y plus d, which is 0. Right, so we're going to have either x over 6 if you want to stack it, or if you want to think about it as being 1 over 6 times x, and then -2y. All right, we're dealing with sine, so the key points start at 0, 0, etc. All right, we're going to take all x coordinates and divide them by 6, or think of it as multiplying by 1/6. All right, so 0 divided by 6 is still 0. I think I'm going to handle the x coordinates first while I'm kind of in that mode of thinking. So pi over 2 is x divided by 6. No, I'd rather take pi over 2 and multiply it by 1/6. So pi over 12. I'll come back and get the y coordinates later. All right, if x is pi, then pi divided by 6, I can just write that down like this. So notice the difference between the first x and the second x is a 1 pi over 12. If I were to check to make sure this is right, I would add a pi over 12 to this pi over 12, giving me 2 pi over 12, which 2/12 does reduce to a pi over 6. Just kind of a built-in kind of stopping and checking. All right, where am I at? Right here? 3 pi over 2 divided by 6. Oh no, I'm going to do 3 pi over 2. I choose, instead of dividing by 6, to multiply by 1/6. 3 divides out here, 3 divides out here 2 times, so I'm going to get pi over 4. And then 2 pi divided by 6, yeah, that's what I'll do there. So 2 pi, if x is 2 pi, I would put that, since I don't have a fraction, I just put 2 pi over 6, and that becomes pi over 3. All right, let's go back and multiply all the y coordinates by -2. That's a 0, that's still a 0, and that's a 0. So -2 is -2 here, and -2 times -1 is 2. So notice that our graph's going to go down first and then back up, and that's because we have that reflection as suggested by that negative right there, that negative multiplier. All right, let's scale our axes. So I'm going from 0 to pi over 3. Pretty much start about the same place. All right, the distance between 0 and pi over 12 is pi over 12, so how many tick marks? I don't know. I mean, really, this is thin, and I'm just actually, stretching it out, which, on the graphing calculator is going to look really thin. So maybe I'll do 2 tick marks for a pi over 12. So pi over 12, pi over 6, which is 2 pi over 12. 3 pi over 12 would be pi over 4, so pi over 4. 4 pi over 12 would be pi over 3. Boy, this thing didn't take very long for it to complete. It's very horizontally compressed. Y values, high is 2, low is -2, so maybe 1, 2. -1, -2. Pi over 6 back to 0, at pi over 3 back to 0, pi over 4, I'm up here at 2. So that negative has us go on the sine graph down first, around, and pick up the maximum, and then come back down. All right. B, where the period begins, x equals 0. Where it ends is x equals pi over 3. This distance horizontally. I can see the answer to the period question is going to be pi over 3, but just to confirm, if I take 2 pi and divide it by b, which is 6, that would reduce to pi over 3. X-intercepts. My pencil's running out here. Pi over 3, yeah. All right, max y equals 2. At x equals pi over 4. Ooh, I don't think I have another pencil either. Yep, that was it. And I don't have another one here. G is, again, this is pi over 12. My pencil ran out, so that's pi over 12. Domain is all real numbers, and your range is -2 to 2 with the brackets around them to include them. All right, perfect timing for the pencil to go out because I was going to end the video there. We're going to complete examples 5 and 6. They take a little bit longer to do, so we'll complete those in the next video.